Alright guys, now we have lesson 4-3. It's called Patterns and Nonlinear Functions. So last chapter we did linear, which were all functions that made a straight line. Now we're going to do nonlinear. So the objective is pretty much the same, to identify and represent patterns that describe nonlinear functions. So this is the getting ready box. I just want to introduce you to how these are going to be nonlinear. So the picture in the book is much better, but I tried to recreate it here. It says the table shows the relationship between the number of steps in a staircase below and the number of blocks needed to build the staircase. Copy and complete the table. Is the relationship a function? If so, is it a linear function? So I've kind of redrawn the picture. If you have one step, you have one block. Now, when we start graphing these, the ordered pair is going to be 1, 1, because the number of steps is your independent variable. So that's going to be on the x-axis, and the number of blocks is your dependent, so that's going to be on the y-axis. Okay, because the number of the number of blocks depends on the number of steps you need. So if we have 2 steps, then that's represented by 3 blocks, and the ordered pair would be 2, 3. And then the third part, if we have 3 steps, that requires, and here we can just count, so 1, 2, 3, 4, 5, 6 blocks. So our ordered pair is 3, 6. So the rest of the table, we have 4 steps, and then we have 5 steps. Okay, so you could redraw the picture, and if you see what's happening, in one step, here's your 1 block, and here's that same 1 block, and then when you have 2 steps, you're just adding 2 blocks below it. Okay, then on to 3 steps, you have these same 3 blocks, but now you're adding 3 blocks onto the bottom of it. Okay, so 4 steps, we're going to have these same 6 blocks, and we're going to add 4 blocks below it. Okay, so we would have 10 blocks, and the ordered pair would be 4, 10. Then for 5 steps, we're going to have this same 10 blocks, and we're going to add 5 blocks onto the bottom of it, so we would have 15. And there's different ways you could look at this, but that's just kind of how I visualized it. So, is it a function? Remember, a function is if you have one x value for every y value. So we have 1, 2, 3, 4, 5. Those are all different, and each of those gets paired with a y value. So it's definitely a function, but is a linear function? Since the x values are going up one at a time, if you look at the number of blocks, from 1 to 3, you're going up by 2 blocks. From 3 to 6, you're going up by 3 blocks. From 6 to 10, you're going up by 4. And from 10 to 15, you're going up by 5. So it kind of looks like a pattern. It goes 2, 3, 4, 5. But it's not going up by the same amount each time. And on a graph, if you're jumping by 2, then you're jumping by 3, then by 4, then by 5, it's not going to make a straight line. So it is a function. It's just not a linear function. Okay, so the vocabulary here. A nonlinear function is a function whose graph is not a line or part of a line. So I took this from the book, and here's a couple examples. So here's a linear function. You have just a regular straight line. We're going to get into continuous and discrete graphs. Discrete is when you just have a bunch of dots, but still they make a straight line, so that's linear, and then a straight line horizontal, that would be linear. Now nonlinear, sometimes they make curves. Sometimes they make like a kind of like an S shape. Now, part of this last graph here, like this looks like a line and this looks like a line, but the whole thing isn't a straight line. This is actually the graph of the absolute value that we're going to do eventually, but the whole thing has to make a straight line. So those 3 right here, and then a whole bunch of different variations, but as long as it's not a completely straight line, it would be nonlinear. Okay, and this is problem 1. It says, it's kind of long. I wouldn't worry about writing it all down because this is just like exactly in your book. So just kind of watch this, and then when we get to the problems with the ordered pairs. Those are what you want to write down. So it says the area A, okay, so that means this area right here in square inches of a pizza is a function of its radius, which is right here in inches. And then we have a different thing, the cost, which is right here, of the sauce of the pizza is a function of the weight in ounces of sauce used. Graph these functions shown in the table. Is each function linear or nonlinear? So here, our independent variable would be the radius. Okay, and then the dependent variable is the area. The area depends on the radius. And then in the second table here, we have weight is independent, and the dependent variable is the cost. So the cost depends on the weight. I just took the pictures from the book, and you can see here, here's graph A. Okay, we have the radius, independent, area, dependent. And when you graph the points, it makes like a curved line. So as long as it's not a straight line, this one right here is nonlinear because the graph doesn't make a straight line. And then when they graphed the sauce, we had sauce was independent, cost was dependent, and that formed a perfectly straight line. So this one is linear. Okay, because each of these is going up by the same amount each time. I don't remember exactly what the number is, but you can see here they're going up by the same amount. Here, it goes up a little bit from 2 to 4, and then a little bit more from 4 to 8, and then, from 4 to 6, and even more from 6 to 8, and then even more from 8 to 10. So it's not going up by a constant rate each time. Alright, now these are definitely ones you want to write down. So, writing a rule to describe a function. It's definitely easier when we have a picture, like we did with the blocks, but here we just have ordered pairs. So they represent a function, it tells you that, and then it says write a rule that describes this function. So my advice would always be put them in a table. So we take the first ordered pair, 1, 2. 1 is the x value, 2 is the y value. And then we have 2, 4, we have 3, 8, we have 4, 16, and we have 5, 32. Alright, now you have to figure out what are you doing to the y value? What are you doing to the x value that gets you the y value? So there's a bunch of different possibilities you could try, like to go from 1 to 2. Well, you could take 1 and you could times it by 2. Okay, see if that works for the other ones. Can you take from 2 to 4, can you take 2, times it by 2, and you get 4? Okay, that has to work for the whole table. So from 3 to 8, if we take 3 times 2, we only get 6. But you're supposed to get 8. Okay, so timesing by 2 is out. You can't multiply by 2. Alright, you could try adding 1. So from 1 to 2, you took 1 plus 1, and you got 2. Does that work when you go from 2 to 4? 2 to 4. So if you take 2 and you add 1, you're only at 3, but you're supposed to be at 4. So adding 1 doesn't work. Alright, a little bit of advice, because I've been doing this for so long, is when you have something that's non-linear, so if it tells you that it's non-linear, and everything in this chapter is non-linear, it usually involves some sort of exponent. So if you've tried multiplying by a constant number, and that doesn't work, or you've tried adding, pretty much linear equations is out of the picture, because that's how you get linear equations. So it's going to probably involve some sort of exponent. Okay, so I'm going to erase all this so that we can try something different. Like think along the lines of exponents. Okay, so let's say we could take, and usually the first ordered pair doesn't help you all that much. So think about how we went from 2 to 4. Well, we took 2 and we squared it, and that got us 4. How did we go from 3 to 8? You could take 2 and you could cube it. 2 cubed would be 8. 2 times 2 times 2 is 8. So kind of if we follow this pattern, 2 squared, 2 cubed, 2 to the 4th is 16, and 2 to the 5th is 32. So then this one must be 2 to the first. Anything to the first power just keeps it the same. Okay, so that's how we're coming up with these numbers. 2, 4, 8, 16, 32. Write a rule, or we might as well just write an equation. So y equals, this column right here equals. Now, you have to look at where your x values are. These are your x values right here. 1, 2, 3, 4, 5. So we always have a 2, and then we're raising it. The exponent is actually our x value. So that's your rule. And these are going to be tough, pretty tough. You're going to have to guess and check, but you're going to see that there's really not that many different variations that you can have. So this is one, like, anytime you see this chart, it's always going to be y equals 2 to the x. But the idea is to figure out how to do them and just try some things with exponents. Okay, so what's the rule for the function represented here? So let's make another xy table. Just because trying to think of all this stuff in your head, it gets way too much. So we have the ordered pair 1, 1, we have 2, 4, we have 3, 9, we have 4, 16, and we have 5, 25. Hopefully you already see the relationship, but again, you could try multiplying. So from 1 to 1, I multiplied by 1. Well, that's not going to work for anything else in the table. Also, from 1 to 1, so timesing it by 1 didn't work. Adding 0, because that's what I did from the first one, also didn't work. So you've kind of eliminated the two things that makes it a linear equation. Now you want to check something that's going to make it nonlinear, which is going to probably involve exponents. Okay, so again, the first one doesn't really help you all that much. Let's look at the second one. So you took 2 and you squared it and you got 4. You took 3 and you squared it and you got 9. You took 4 and you squared it and you got 16. You took 5 and you squared it and you got 25. So probably we took 1 and we squared it and we got 1. So our equation is going to be y equals. Now this time, look at where your x values are. Here's your x values. 1, 2, 3, 4, 5. So you're taking your x value, and then what's constant in all of these is that you're always squaring it. So the equation is y equals x squared. So go ahead, try on the lesson check on page 249. Again, it's 5 questions. It's just asking you, is it linear, non-linear? And then you can try 2 of the problems like we just did, taking the ordered pairs. I would write them in a table. One even gives you the table. And then trying to come up with the equation.